What's up, YouTube? Alright, so today I just want to change things up a little bit. I know most of the time I record and publish covers and videos of me playing the guitar and that type of thing. But today I wanted to do a little something different, and in the future I think I'm going to start making more of other types of videos, tutorials and you know, things about guitars and amps and other things that I'm interested in as well. So it won't be just strictly music from now on, I don't think. Anyway, today I just wanted to kind of explain a little bit about how tube amps work, because it's something that really fascinates me and something that I'm really interested in, and I'm just learning a lot of it myself, but I know enough that I think I can make a good video to help some people who are just starting to learn. So behind me I've got my 77 Marshall JMP 2203. It's 100 watt master volume model, and what I'm going to do is I'm just going to turn it around and show you the insides and kind of point out the different parts and what they do, because when I kind of started learning this stuff, I looked for a lot of different videos, and there were a lot of ones that kind of showed everything on paper but didn't really show you the inside of the amp and like point to the different parts. So let's get started. Quickly, this is very important. If you don't know what you're doing, please do not mess around with the inside of your amplifier. There are capacitors in there that can, even when it's unplugged and powered off, that can store hundreds of volts that can seriously hurt you or even kill you. So if you don't know what you're doing, please don't open it up, please don't mess around with it. If there's something that needs repair, take it to a technician, and if you don't feel comfortable with it, just don't mess around with it. Alright, let's get started. So first, what I'm wanting to do is I'm going to just kind of point out the different components and tell you what they are, and then I'm just gonna explain a little bit about what each one of them does, and I might get into a little bit of the theory of it. Alright, so this big thing here is the power transformer, okay, and this one is the output transformer. These, obviously, are the tubes. These three smaller ones are the preamp tubes, and these four bigger ones are the power tubes. Behind that, you can see, this thing is called the choke, and then these blue things are capacitors, specifically filter capacitors. Alright, so let's talk a little bit about what each one of these things does. So let's start with the tubes, seeing as this is a tube amp. Now, as I stated, these smaller ones here, these are the preamp tubes, and these bigger ones are the power tubes. So what happens is the preamp tubes are what your guitar signal hits first, and what their job is they do a couple of things. They first amplify the signal before sending it off to the power section. So they amplify the signal, and these are also where you get your preamp distortion. And if you have a distortion or a gain knob on your guitar amp, these tubes are what adjust that. So the more gain that you use, the more signal is being fed through these, and the more aggressively they amplify that. And the power tubes are a little bit different. What they do is they take the smaller amplified signal from the preamp tubes, and they really amplify it quite a bit more and send it out to your speakers. So they really kind of work in the same way, although they do kind of two different things. So let's look at what else we have here. power transformer. What does that do? Well, that's where your power supply comes from. When you plug your guitar amplifier, your guitar amplifier, when you plug that into the wall voltage, if you're in the US, is should be around 120 volts. Well, guitar amplifiers need much higher AC voltage, DC voltage, to run. And amplifiers like this use both AC and DC voltage inside. So this power transformer takes your wall voltage and steps it up to a higher voltage, and also steps it down to, there are a couple outputs for 6.3 volts. And the 6.3 volt outputs are what power the heaters in your tubes. So when you switch your amp on, you hit that first power switch while it's still in standby, you can see that the tubes start to heat up and the heaters start to glow orange. And I'll talk in a minute about what that does. How exactly does it all work? Well, let's take a look. What happens is, like I said, with your power transformer, it has a winding on the secondary. You have a primary and a secondary in there. And what happens is, on the secondary there are what are called taps for 6.3 volts. And those 6.3 volts are what power the heaters, or what are also called the filaments, in the tube. Now, inside the tube, those filaments glow red hot. And also inside the tube you have some different parts called a cathode and an anode. Now what happens is the filament heats the cathode, and when that happens, let's see if I can get a better shot there. You can see that's glowing bright orange. The cathode essentially boils off electrons, but it can only do this if it's heated up. So if it's not heated, the electrons won't flow. And the electrons flow from the cathode to the anode. Now we have to remember that electrons have a negative charge. So like charges repel and opposites attract. So the electrons, which are negative, they go from the heated cathode and they fly across to the anode, which is it's really the inside of that kind of blackish plate in there. And in between those, there's what's called a grid. So what happens is, when you turn your amp off of standby, which I'll do here, I'm going to turn the lights off so that you might be able to see it. Alright, so now the heaters are, they're heated up. We waited for the amp to heat up. And now, if I take the amp off of standby, you may be able to see a bit of a bluish glow. And what that is that's some of the electrons that are flying off are actually flying past the plate and they're hitting the glass. That's what you're seeing there. Now, if I turn up the guitar and I play a chord, you can see that it glows quite a bit more. And that's because there's more current flowing through because of my guitar signal. So essentially what we know so far is that the guitar signal travels through the preamp tubes and then the power amp tubes. And we know that the power transformer, the one back there, we know that gives us our power supply and that powers the heaters. But what about this other stuff? Well, let's get into it. After the signal goes through your tubes, it has to get out to your speaker cabinet. But tubes are high voltage, low current devices, while speakers are low voltage, high current devices. So there has to be something that matches them. Well, that's what this is back here. This is your output transformer. And that's why it's also sometimes referred to as a matching transformer. It basically does the same thing that your power transformer, the one back here, does the same thing. It just transforms the voltage and the current. So once your signal gets through the power tubes here, it's very high voltage and low current. And like I said, the speakers need low voltage and higher current. So the signal gets sent through your output transformer there, and that's how it gets matched with the speakers. Now what about these blue things? Well, those are capacitors. Capacitors are kind of like batteries. They're able to store electricity on their most basic level. But what their purpose is here, at least the ones back there, they're called filter capacitors. And they're exactly what they sound like. They filter things. But they're more important to the power supply than anything. So we need to know a little bit about the difference between AC and DC voltage in order to explain their purpose. So I'm going to get some paper and I'll draw that out so we can understand it. Alright, so there are essentially two types of electricity. We have AC, which is alternating current, and DC, which is direct current. And if you look at these on a graph or an oscilloscope, alternating current is a sine wave. So you'd see it moving something like this. While direct current is a constant voltage. So it would be a straight line like this. And this line is 0 here. So in the United States, AC voltage is, at the wall outlet, it's 120 volts, which is a positive peak and a negative peak. And it cycles at 60 hertz, which means 60 times per second. And so you get these waves here that are happening 60 times a second, and it's 120 volts positive, and it's 120 volts negative. Well, like I stated before, in the amplifier we need both AC and DC voltage for it to function properly. So, if we only have AC voltage at the wall, how do we get the DC? Well, in the amplifier there's something called a rectifier. A rectifier is something that converts AC to DC. In the amplifier that I just showed you, it has a solid state rectifier which uses diodes, but some amplifiers have a tube rectifier. And they both do the same thing, although they may sound a little different and operate a little differently. Basically what happens is, the rectifier, you have this AC voltage that's coming in these waves. What the rectifier does is it flips, well actually there's two types of rectifiers. There's a full wave, and then there's a half wave. So if you have a half wave rectifier, all it does is cut off the negative parts. So you'd have something that looks like this. So you'd have a bunch of bumps of positive with these gaps in between, so that's not very helpful to us. So what we have is called a full wave rectifier. So it keeps these positive bumps, and then it takes the negative ones and flips them over. So your power supply kind of looks like that. Well, this can cause some problems because we can get noise from this. this can cause hum, which you may sometimes hear in an amplifier. It can cause hum or just other general noise. And so we want to get rid of these bumps. How do we do that? Well, that's where the filter capacitors come in. Because the capacitors can store energy, once this electricity hits the top of this peak, the capacitor stores some of that energy. So instead of being a very pointy peak like this, it would look something more like this. So it would still look a little wavy, but it would be much more smooth. Now what will happen is if you put it through multiple capacitors, eventually it won't be perfectly flat, but it'll be more like that. And since it's all moving in one direction, we have our DC voltage. So how do the tubes themselves work? Well, let's take a preamp tube, for example. Essentially what you have is a glass bottle, like this. And this is if you were looking at it from the top, or maybe this is more like a schematic view. You have, in the preamp tube, you essentially have three elements. And I'm just going to draw them like this. So this here is your cathode, this is the anode, and this is called the screen, or the grid. And then under this, it's not really necessary to draw it in, but you'd have your filament or your heater, which would heat this up. So now we have to remember what happens is this is negatively charged and this is positively charged. Now since electrons are negative, they want to flow to the positive. But this grid here has a slight negative charge on it. Since like charges repel, these electrons stay here. What we can do with this is take our guitar signal and send it to that grid. And with a guitar, when you hit the strings, that causes a magnetic field to vibrate and essentially generates a very small amount of AC voltage. Now remember, AC voltage is like a wave, like this. So let's say you strike a note or a chord. That tiny AC voltage is going through this wire to this grid. And when you hit that note, it's going to create positive peaks in the voltage and negative peaks. Whenever the positive peaks happen, this grid becomes slightly positive, allowing the electrons to flow through it to the anode. And in doing so, it amplifies the signal. So this amplifies the signal because the AC small signal from your guitar is basically acting as a gate that's opening and closing very quickly. And what happens is whenever it opens and it's positive, that lets the electrons flow through, and thus they are amplified because you have a large amount of them going through at once. So basically you're just using this to control the signal that's going through. So that's basically how tubes work. Now this is called a triode because there's three parts: the cathode, the anode, and the grid. And this is what is in preamp tubes. But preamp tubes are generally dual triode, which means there's actually two tubes in one. So you'll have this same setup twice in the same tube. The preamp tubes in the amp I showed you are called 12AX7s. Over in the UK and Europe they're referred to as ECC 83s, but they're the same exact tube. but they function the same way as this. And this is basically the same way that all tubes function. Same for power tubes, same for rectifier tubes, except they may have fewer or more components. Rectifier tube won't have this grid, and power tubes may have an additional grid or two. If you look here at this preamp tube, you can see that there are two different elements inside, and that's what I was saying, it's a dual triode. Basically there are two tubes in one glass envelope. So I'd like to talk just a little bit about gain. So in most guitar amplifiers you have what's called cascaded gain. And I said before that the preamp tubes are what give you most of your distortion. Now, there's also power tube distortion, but that's a little different, and I'll talk about that in a minute. So what happens with these preamp tubes is they're cascaded. So what happens is your guitar signal hits the first triode in here, and it's amplified. Well, then it hits the next one, and it's amplified more. Then it's sent over to this one, and it's amplified in both of those. And then it's sent over to this one, and it's amplified in both of those. And what happens each time you amplify it, the more you turn up the gain, essentially you're turning up the amplitude of that wave, and the tube can only handle so much of that, essentially. And so what happens is the waveform clips or distorts. And the reason that people like tube amplifiers is usually because the way they distort, usually the waveform clips a little more roundly, whereas a transistor would clip it flat. The tubes clip it a little more roundly, and it tends to sound a little better. And that's why people generally prefer tubes, one of the reasons. Now with your power tubes over here, you also can get power tube distortion, and this is what people really like, but the problem is that only happens when you crank the amp, and generally that is too loud for most applications. So in a future video I'm going to talk a little bit about what you can do to get around that. So I mentioned before about your transformers. Here you have your power transformer and your output transformer. And then we have this thing back here called the choke. And while that looks kind of like a transformer, it's actually not. It's what's called an inductor. And it kind of does what it sounds like. It's called a choke. What it does is it chokes out any residual AC signal, hum, and basically tries to eliminate any more noise before it's sent out to your speakers. And not all amps have this, and it's not completely necessary. Some might just use more filter capacitors or some other means, but basically that's what it does. Alright, if you have any questions, just can give me a comment, or if you want to message me, that's fine, and I'll try and answer them as best as I can. And if I can't answer them, I'll try and refer you to someone or a resource that maybe will help you. I'm going to post a link down in the description of a webpage that has a lot of great info on how amps work. And I'd also just like to mention the YouTube account Uncle Doug. He has a bunch of videos explaining different parts of amps and how they work and all the theory behind it, and I learned a lot from those videos, so I'd encourage you to check them out. Well, obviously it gets quite a bit more complicated than this, and there's the internal circuitry and all that. I'm not really going to get into that, and I'm still learning a lot of this stuff, so there's probably a lot that I couldn't tell you about it. But I just kind of want to do a little overview of the different parts and what they look like, and just kind of point them out, so if you're looking at your own amp, you can kind of tell on your own what the parts are and just a little bit about what they do. So I hope you guys liked this video, and thanks for watching, and I'll see you next time.